First of all, any questions from any homework? Homework's going okay? I'm an optimistic fool. Hey guys. Second. We're not in 5-1, so yeah. Yeah, so today we're getting into chapter 5. So there's no questions on homework. I just want to lecture a little bit on some basics about decimals, and then let you guys try some problems out of the blue book. I'll put them up on the board in case you didn't bring it with you. Somebody. Let me make these all different. So first thing is, I'm always surprised about how few people know this. Almost no matter which math course I'm teaching at the moment. What are the places, like what place is the 1 in? Let's start off nice. What place is this?
10,000.
That's a
10,000.
that's a decimal. Yeah. Sorry.
The 10.
So it's the tens place. So the 1 is in the tens place. Okay. What about the 2?
Tenths.
Careful. So here's how you count it all.
10,000.
Every step you take, this is the hundreds place, right? This is the tens place. Notice how it decreased by a factor of 10. You with me? 100 divided by 10 is 10. So 10 divided by 10 is 1. This is the ones place. So 1 divided by 10 is 1/10. So that's the tenths place. Cool. The 2 is in then, what's 1 divided by 10 twice? What's 1 divided by 100? That's the hundredths place. Hundredths place. And of course the 6 then would be in the thousandths place. And then you just keep going from there. Okay. And I really want you guys to understand this. And I want to make this connection. I don't want you to feel like decimals have the same difficulties fractions do. Fractions are difficult. Decimals are difficult for different reasons. But decimals really are fractions. They're just special fractions. Right? What's our number system based on that we use? Our number system is based on 10. Most likely because we have 10 fingers.
I was going to say 5 fingers.
I like that. I was waiting for somebody to say, it's based on our fingers. In a way, yes. Right? That's the best theory going right now is because we have 10 fingers, it was only natural to use them as a counting tool. In fact, there's a group of people, I can't remember where they are now, on an island, like a little tribe, and they count toes up the side of the body, fingers down the other side of the body, so the names of their numbers are related to the names of those body parts. It's kind of neat. So it's only natural for us to count using fingers. If we would have had 8 fingers, maybe not lose the thumb, because that let us evolve. So maybe lose the finger there. So we have 8 fingers. Our number system would have been based on 8. That is really hard for us to understand because 10 is natural to us. It's what we've been brought up with. So fractions that are out of 10 can be written as decimals because that fits into our number system. And what I really mean by our number system is based on 10, every step we take is increased by a factor of 10. So if our number system is based on 8, every step we would take would be increased by a factor of 8. That's freaky as hell. We're not going to talk about that more than I just did, right? But I want you guys to realize that's the reality of the situation. So let's just focus on one piece of this number. How could I say that in English? Don't say 0.3. Put that off right there, sorry. I like it, I like that. 3/10. Good, because it's in the tenths place. So it's 3/10. So in English, this is 3/10. Now, when I say 3/10, what, do you have a fraction that comes to mind when I say 3/10? What fraction is that?
3/10.
3/10. So that is a fraction based on some multiple of 10. Therefore, I can write it as a decimal. Other fractions I can't write as decimals until I convert them to something out of 10 or 100 or 1,000. So if I wanted to go the other way, if I have 5, let's make it, that's good, 5 hundredths. So in English, this is 5 hundredths. How would I write that as a decimal? Yeah, I can't put it here. I have to put it here, exactly. So that's 5 hundredths. Cool. All right, how are we doing so far? Doing pretty good? Somebody's in sort. Okay.
So is that because you have the 2 zeros down at the bottom of the 100, at the 100? What makes it that?
Yeah, one way to look at it is it's 2 places back because of this. And where things get a little bit more interesting is what about like 27 over 100?
.27.
Yeah, good. 0.27.
Yeah.
The last number in that is in the hundredths place. All right, so that's how I write 27 hundredths. If I wrote this, what would this here be? What place is that in?
20,000.
Good. This is 27
Thousands.
thousandths, or otherwise known as 27 out of 1,000. Okay. All right, so these are real basics. Right. Some of us need a refresher.
Yeah, I need a refresh.
That's cool. Some of us are like, all right, dude, just hang out. All right, I want to make sure everybody's on the same page. So if I had something like 3/5, how do you think I could try to work that into a decimal? Yeah, one way to do it is divide it. Now we know another way. Can't I make the bottom 10? How do I make the bottom 10? What do I have to do? Times 2. So what is this as a decimal then? 6/10.
0. I mean, point 0.
Yeah,
10.
0.6. So that's 6/10. Cool. That's quicker than the 5 goes into 3 how many times? Right? Isn't that quicker? So if I can make the bottom some multiple of 10, that's a really cool, quick way to change it into a decimal. Because decimals are fractions based on multiples of 10. If I have something like 1/3, can I make 3 into 10 or 100 or 1,000? Screw it. That one I'll just go ahead and divide. Right? We can get, no, I won't put it. But if the bottom is a number like 5 or 10 or 20, 25, anything I can make it to 10 or 100 or 1,000 easily, that's a quick way to make it into a decimal. And some of you guys know, not too far in the future, we're probably going to take the next step and talk about percentages from there. How to convert from decimals to percentages. Let's see. Oh, so I like that. I want to make really sure that everybody's cool with this fact that 27 out of 100 is 0.27. That tends to trip people up a little bit when we start thinking about that's the hundredths place, but I can't put the 27 in the hundredths place, right? Are we all semi-cool with that? Okay, so I don't want to break that down too much and confuse it, super cool with that. Okay, one last thing. What was it before I break you out into groups? Oh, yeah, this is where things get a little bit tricky. Let's see. Let's see. Which one of these is, which one of those is bigger? Which way would I put an inequality symbol? Which one's bigger?
0.9.
So you,
0.9.
maybe, no.
9-1.
Yeah, this one's bigger.
Yeah.
And it's really, it's kind of a, it's not a trick question, but it's kind of the way I've written it, it's not immediately obvious. But what can I do at the end of any decimal?
Put a 0.
Yeah, because what is this as a fraction? 9 over 10. Can't I multiply that by 10 on the top and bottom? I can multiply that by anything I want to on the top and bottom. You with me? So what happens if I multiply it by 10 on the top and bottom? What does it become now? 90 over 100. And what is that officially as a decimal? 0.90.
Yeah.
So I can keep adding on zeros, and it's going to still be 9 over 10. It would always reduce back to that. So I can put on here as many zeros as I really feel like it, right? People tend to think that if you don't really understand that, you're like, why can I go ahead and do that? Because it all reduces back down to 9/10. That's really all there is to it. So now if I do that, now that's easy to compare. Now I can tell 91 somethings is bigger than 90 somethings, right? So it would definitely be like this. So when you have that kind of problem, we have to compare decimals, just make them have all the same number of decimal places. But it is just a straight comparison. Cool. All right, so let you guys do a few problems. How many of you guys, let me see which book we have more of. How many of you guys have the blue book with you? How many of you guys have the regular textbook with you? Okay, cool. I think it's more of this regular textbook. So let me pick a few out of the regular textbook. This is off of page, actually now this is kind of cool, I just do the review. Page 392. No. We're going to talk about these. That's good to get us started. Let me see if I can do this.